Hello everyone, and welcome to another GIS lecture video. And in this lecture video, I want to talk about the next type of overlay, which is union. So with union, again, to kind of draw out our quick little example here. Right. And again, don't forget the attribute tables. And I think it's always helpful just to kind of keep reiterating this point, that what we end up with is a new attribute table, right, with all the possible combinations of geometry. Right. So right. And then from this list, we can think about which ones we are getting rid of based on the type of overlay. So union is actually really easy because union keeps everything. Right, specifically keeps any overlaps plus all original geometry. So the union keeps all overlaps plus any original geometry. So that's a fancy way of saying that it's going to keep all three of these records. Okay, union's pretty simple in that way. So let's go ahead and take a look at a slightly more clean example. Right, so again, here we have, right, our two data sets, A and B. And just like before, right, it's going to have the same cut, right? We're going to cut it all of the overlaps. Right. And then again, because we're dealing with overlay analysis, it's not just the geometry, right? In this result, though, right, we keep all the pieces. So before, right, we had, and again, I messed the labeling up there when I was writing it, but right now we have 8 pieces, right? We have 1, 2, 3, 4, 5, 6, 7, 8, right? We have all the overlap like we had from intersect, but then we also have the original geometry that was left over. So we went from 2 data sets with 4 pieces to 1 data set with 8. And again, more critically, right, we have all of the attributes from both the attribute tables merged together. Now, one thing I want to make a note of and make sure that it's clear, when we did intersect, right, there were no pieces of geometry, right? There were no features that didn't have variables from both because the only geometry we kept was geometry with overlap. But because we're doing union, we're keeping all the geometry, even the ones that don't have overlap. And what you end up with, like in the case of 1C here, and 1C is the original 1B, right? Or what's left of 1B after overlap, right? you'll see that because this 1B piece here doesn't overlap with A at all, right? And you saw this a little bit in the examples that I've been doing in the beginning of the videos, but you actually have NAs. So there's no data because there's nothing from A because there's no overlap, right? Compare that with 2C, right, which is the overlap, and this would have been one of the pieces from the intersect, right? It does have data for both. So just keep in mind when you're dealing with a union specifically that you will end up with instances where there are NAs in the data because there's simply no overlap in the original two data sets. Hopefully that makes sense. So let's go ahead and look at another sort of more realistic example. And in this case, right, we have our farm fields from the intersect example. So we have the owner and the crop type. But now we're overlaying them with counties. So the counties have a name and the counties have a supervisor. And you can see that because the counties and the farms don't line up, there are certain parts that are owned. There are certain parts of the county that own different parts of the farm. And so what we want to get at is we want to get at a new data set that tells us which, for every possible plot of land, right, either does it have a farm or not, and if it does have a farm, who owns it, and what county does it belong to. So this would be all of the possible data sets, right? And so if we go ahead and run this, you can see here that we get a lot of possible overlaps, right? There's actually 18 of them. 19 of them, right? Because it's not just each possible overlap on the inside, right? But it's also all of the geometry on the outside. So if we look at the attribute table, right? Again, I just want to reiterate the point here that there are going to be certain attributes for certain features that are NA. And that occurs because in this case, right, 1C here, right, is the same as 1B minus the overlapping part here, right? So it's 1B minus this, right? So because there's no overlap, right, this 1C represents that portion of Nassau County, right, that is not farmland, right? So it doesn't have a farm owner and it doesn't have a crop growing on it. And because there's no A, the attribute is also NA. So again, just keep in mind with union that you can have data sets that have NA. That's okay. And that just means that in the original data sets, there was no overlap. So let's go ahead and do a review question. So just like before, right, we're going to go ahead and fill in some blanks. So take a second, pause the video, work through the problem, and hopefully come up with the answer. Okay, so let's go ahead and work through this together. So you can see here, right, that we have two data sets. We have the sort of green cloud-shaped ones, and we have the purple boxes. And then the results, right, again, because we did union, we've kept all of the geometry, even this one down here that had no overlap at all, right? And so we're going to do the exact same thing we did before. So let's go ahead and start and kind of work top to bottom, left to right. So, right, we have 1C, and we're looking for the OID from the A attribute table. So, right, looking at 1C, 1C corresponds to the area of 2A without overlap, right? So because of that, we go down to the 2A attribute table, and we say, we go down to the A attribute table, we look at the 2A row, and we grab the 2A OID. Right? So now let's look at 2C. So for 2C, right, we want the name associated with we want the value associated with the name attribute of the A attribute table, and we want the one associated with 2A. So again, I'm going to kind of skip the visual part, and I'm just going to use the fact that we're in the A table to go to the A table. Use the fact that we're looking at 2A to find the 2A row. And I'm going to go ahead and I'm going to grab Haiku. Right. For C, right, now we're in the B attribute table. And in specific, we want the B attribute that's associated with 3C. So if we look at the visual here, we see 3C. 3C is associated with the 1B overlap, or the 1B without overlap, I should say. And so we know that that's 1B. For 4C, right, we're looking for the PID attribute from 1B. So we're going to jump to 1B, find PID, it's 5029. Right, for 5C, I'm going to walk through this one a little slower because it's the first instance of an NA. Now, you could quickly look at it and say, okay, 5C corresponds to 1A. Since 1A doesn't have any overlap with B at all, it's NA. 6C, we want the structs from 2B. So we're going to go to the B table, go to 2B, grab the structs. So that's going to be no. Right. For 7C, right, we're going to the B attribute table and we're grabbing the 3B PID. So that's 7936. Right, and then finally 8C, we want to grab the OID. So 8C corresponds to 2B, completing the attribute table. Hopefully that makes sense. And again, as always, if you have any questions, please reach out. Thank you.